Hello everyone. Now in the last video, we have started the chapter Speed, Distance and Time. And in the last video, we discussed the basic questions and the average questions of the speed, distance, time. Now in this video, we will continue the chapter Speed, Distance and Time. Now today we will discuss a next topic where speed, distance, time is constant. Now, so in this video, we will discuss those questions which is based on either your speed, distance, your time is constant. Only one thing will remain constant. Now, so we know that distance is equal to speed into time. Now, the case first when distance is constant. So when the distance is constant, we can write in the formula d1 is equal to s1 into t1. d2 we can write in the form of s2 into t2. Distance is constant means d1 is equal to d2. If d1 is equal to d2, then s1 into t1, which is equal to s2 into t2. Here we can write in the form of s1 upon s2, which is equal to t2 upon t1. Means the ratio of s1 upon s2, which is equal to t2 upon t1. Clear? Now, the first case when the distance is constant. Now, we will move to the another case where second case where speed is constant. When the speed is constant, we can write s1 is equal to d1 upon t1, s2 is equal to d2 upon t2. Speed is constant, s1 is equal to s2. Now we will write d1 upon t1 is equal to d2 upon t2. Yeah, we can write in the form of d1 upon d2, which is equal to d1 upon d2, which is equal to t1 upon t2. Now this is very important. Now in the question when the distance is constant, so we can write in the form of s1 upon s2, which is equal to t2 upon t1. When the speed is constant, we can write in the ratio d1 upon d2, which is equal to t1 upon t2. Third case, when time is constant. When time is constant. When the time is constant, we can write t1 is equal to d1 upon s1 and t2 is equal to d2 upon s2. So we can write in the form of s1 upon s2, which is equal to d1 upon d2. Clear? So we have to remember this ratio term. When distance is constant, we can write in the form of s1 upon s2, which is equal to t2 upon t1. Speed is constant, we can write d1 upon d2, which is equal to t1 upon t2. When the time is constant, we will write s1 upon s2, which is equal to d1 upon d2. Clear? Now based on this property, we will solve some question. Now, question number 1. Two trains start at the same time from two stations and proceed towards each other at the rate of 20 km per hour and 25 km per hour respectively. When they meet it is found that one train has traveled 80 km more than the other. Find the distance between the two stations. So what will be the distance between the two stations we have to find? Now, first of all, we will find out what is the constant, whether it's speed, time, or distance. Two trains start the same time from the two stations and proceed towards each other. 20 km per hour and 25 km per hour respectively. When they meet, so the time travel by the first train, which is equal to the time taken by the second train, at the same time they will meet. So the time taken by the first, which is equal to the time taken by the second train. So in this case, we can say time is constant. When the time is constant, we know that d1 upon d2, which is equal to s1 upon s2. d1 is the distance covered by train 1, d2 is the distance covered by train 2. S1 is the speed of the train 1, S2 is the speed of the train 2. So d1 upon d2. Now the speed of the train 1 is 20 km per hour and the speed of the train 2 is 25. So we can write d1 upon d2, which is equal to divided by 5, 4 by 5. Now here we get the ratio of d1 upon d2. d1 is the distance covered by train 1. d2 is the distance covered by train 2. d1, train 1, d1 is 4, d2 is 5. Now the difference of 4 and 5 is 1. 1 is equal to 80 kilometer because it is found that one train has traveled 80 kilometer more. Difference is 1 unit, which is equal to 80 kilometer. 1 unit is 80 kilometer. So d1 4 into 80, 320 kilometers. d2 5 into 80, 400 kilometers. So we have to find the distance between the both stations. So d1 is the distance traveled by train 1, d2 is the distance traveled by train 2. So we will add these two distances and then we will get 720 kilometers. 720 kilometers is the distance between the station 1 and 2. Getting my point? d1 is the distance traveled by train 1, d2 is the distance traveled by train 2. So time is constant. We know that at the time, when the time is constant, d1 upon d2, which is equal to s1 upon s2. Here, after solving all these terms, we will get the distance between the two stations, which is equal to 720 kilometers. Now come to the second question. Now, if you are getting any difficulty while solving the question, yeah, in the solution, then you can ask in the comment section. Clear? Now, the second question is that a train running at 7 by 11 of its own speed reached a place in 22 hours. How much time would be saved if the train would run at its own speed? Now, in this question, distance is constant. Here, distance is constant. So, S1 into T1, which is equal to S2 into T2. A train running 7 by 11 of its own speed. So, we will take initially its own speed is 11x. The time taken is T1. Now, 7 by 11 of its own. So, own speed is 11. So, the new speed becomes 7 by 11 into 11x, which is equal to 7x. And the train taken 22 hours. 22. X cancel. Here is 2. So, the own time, which is equal to 14 hours. Currently is taking 22 hours. So we have to find how much time could be saved if the train would run at its own speed. So how much time we can save? 22 minus 14, which is equal to 8 hours. So we can save 8 hours if the train moves at its own speed. Getting? Now in this question, distance constant. The next question. A man with 3 by 5 of his usual speed reaches the destination 2.5 hours late. Find the usual time to reach the destination. This is a very simple question. Now in this question, what is the constant? The constant is distance. Now in this question, distance is constant. So if the distance is constant, we know that S1 upon S2, which is equal to T2 upon T1. A man with 3 by 5 of his usual speed. Now we will take usual speed is 5. So new speed become 3. We will take usual speed is 5x. Then 3 by 5 into 5x, it become 3x. So we will take in the form of x. So S usual upon S new, which is equal to T new upon T usual, S1 T1, S2 T2, speed usual, time usual, speed new, time. Yeah, inversely proportional to each other. Now, Tn upon Tu, which is equal to, now this one, usual speed, how much? 5x. New speed, 3x, x cancel. Difference of their time is 2. This 2 unit, which is equal to 2.5 hours. Getting my point? Here is the ratio. This is the ratio. We know that the value of SU is 5x. Sn is 3x. Just put this value here, 5 and 3. New time will be 5x and usual time will be 3x, yeah, in the form of unit. So difference will be 2. 5 minus 3, 2, which is equal to 2.5 hours. 1 is equal to 2.5 upon 2. And we have to find the usual time, which is equal to 3. This 3 is the usual time. So here we will get 7.5 upon 2, which is equal to 3.75. Option number 4. First of all, distance is constant. When the distance is constant, S1 upon S2, which is equal to T2 upon T1, and use usual speed upon new speed, which is equal to new time upon usual time. So here we will put the value of usual speed is 5, new speed is 3. After solution, after solving all these terms, we will get the new time. Sorry, we will get the usual time. In case you have to find the new time, so new time will be the 5. 3 is the usual time. When you multiply by 5, 2.5 upon 2 into 5, you will get the new time. Getting? Now, next question. Same question is there. Walking at 3 by 4 of his usual speed, a man covers a certain distance in 2 hours more than the time taken he takes to cover the distance at its usual speed. The time taken by him to cover the distance with his usual speed is. Same question is there. Now in this question, distance is constant. So S1 upon S2, which is equal to T2 upon T2, we will write in the form of usual speed upon new speed, time new upon time usual. 3/4 of is usual speed. Now we will take the usual speed is 4x. So new speed become 3 by 4 into 4x. 3x. Now we can take the usual speed any value x, y, z. Why I am taking the 4? Because it is a 3 by 4. 4 will be cancelled. That's why I am taking it. 4. Usual speed is 4x. Huh. So new speed becomes 3x, which is equal to time new upon time usual. So time new become 4x, time usual become 3x. Difference is x. Now this x, which is equal to 2 hours, and we have to find the usual speed. Time taken by him to cover the distance with his usual speed means usual time. X is 2, 3x, which is equal to 6 hours. So he will take 6 hours to cover the distance with his usual speed. Getting my point? Now, come to the next question. The question is very simple, not tough, but you have to solve it. Clear? The same question will come in your examination. The language will be the same, but here is the difference only in 3 by 4, 5 by 6, 7 by 8. Language of the question will remain the same, but you have to understand what the logic behind it. Getting the question become very easy. If you understand the question, you can easily solve. Now, next question. Same question is there. Here is also distance constant. Now, usual upon new is equal to T new upon T usual. Here, usual speed we will take 4 and new speed become 3x T new upon T usual. Here the difference is x, which is equal to 20 minutes. And we have to find the usual time taken by him to reach the office. 3x into 60 minutes. So he will take 60 minutes to reach the office. Now, within 30 seconds, 20 to 30 seconds, you can solve this question. Now the second 30 seconds is more. Within 20 seconds, under the 20 seconds, you can solve this type of question. First, you have to understand what is the constant. After that, you will apply the method and you will get the answer. Now, the next question. A is twice as fast as B. B is thrice as fast as C. Now we will take the speed of C is x. B become thrice, 3x. A is twice of B. The speed of A become 6x. The journey covered by C in 42 minutes, x into 42, will be covered by A in. The distance is constant. Speed of A is 6x into time by A. X cancel 7. So the time taken by A will be 7 minutes. Simple question is there. Now, first of all, we will take the speed of C is x, B will become 3x, A become 6x. After that, now in this question, distance is constant. So S1 into T1, which is equal to S2 into T2. Now, next question. A certain distance is covered at a certain speed. If half of this distance is covered in double the time, the ratio of the two speed is. Now, first of all, we have to find the ratio of the two speed. The first speed is V1 upon T1. This is the first speed. Here we can take in the form of S is equal to D upon T. Simple. Now, second, if the half of this distance S1, now the S2, half of this distance D by 2, and it double the time 2T. So we can write in the form of D upon 4T. And we have to find the ratio S1 upon S2. So S1 upon S2, which is equal to d by t and d upon 4t. We will write in the form of d into 4t upon t into d. dd cancel, tt cancel. We will get 4 ratio 1. So the ratio of the speed, which is equal to 4 ratio 1. Speed is given. First speed is d upon t. After that, speed 2. Half of the distance. Half means d by 2. And double the time. Means in the first case, he is taking 2 hours. Now in the second case, he will take 4 hours. So 2t. After solving, we will get d by 4t. Now the ratio become 4 ratio 1. Next question. You arrived at your school 5 minutes late if you walk with a speed of 4 km per hour. But you arrive 10 minutes before the scheduled time if you walk with a speed of 5 km per hour. Find the distance of your school from your house. Now, these type of question, when you are moving with some speed and you become late, after that you increase or decrease your speed and you reach the destination before or after the time. Now, when the question comes in the when the question comes in this form, the language of the question will remain the same. First, you will late, yeah, early. Second, you will late, yeah, early. Language will remain the same, and you have to find the distance of the your school to house. In this type of question, you will remember the fun formula. Distance is equal to S1 into S2 upon S1 minus S2 into time. If the time is given in second, yeah, in minute, so divided by 60. If the time is given in hours, no need to divide it by 60. Clear? First of all, you will remember S1 is equal to S2. Always take in the maximum, the higher value is S1 and the lower value is S2. So S1 is given 4 kilometers, but two speed are given 4 kilometer and 5 kilometer. 5 kilometers more, so we will take S1. 4. 5 minus 4 into time. Time, what time? Time, it is the late, 5 minutes late. And second time is 10 minutes before, early. Now, here is the late. Here is the before, early. In case of late and early, we will add these two times. 50. Time is given minute. Speed is given kilometer per hour. So now this time we will convert into hour divided by 60. Clear? So 5 minus 4 is 1. Here is 15. 15, 15 cancel. You will get 5. So the distance between school and his house, which is equal to 5 kilometers. Just remember this formula. You can easily get your answer. The language of the question will remain the same, but change is its term. Like that, 4 kilometer speed is changed, time will be changed. In case of late and early, you will add these both time. When the time is given in minute, divided by 60. When the time is given in hour, no need to divide it by 60. Remember this thing. Now, next question. The student goes to school at the rate of 5 by 2 km per hour and reaches 6 minutes late. If he travels at the speed of 3 km per hour, he reaches 10 minutes earlier. The distance of school from the house home we have to find. The same question is there. Simple formula. S1 into S2. S1 minus S2 into 10. Now 5 by 2 and 3 is given. So here we will take 3, 5 by 2. Now 3 minus 5 by. Here is late. It is earlier. We will add these two numbers. Time will be at divided by 60 because the time is given in minutes. So after solving all these terms, we will get 15 by 2 here, 1 by 2 into 16 upon 60. 2 cancel. Here is 4. Here is 4. You will get 4 kilometers. So the distance between the school and his house, which is equal to 4 kilometers. Clear? You just remember this formula. You can easily get your answer. Now, the last question. Ram travel a certain distance at 3 km per hour and reaches 15 minutes late. If he travels 4 km per hour, he reaches 15 minutes earlier. Find the distance. Same formula will be used here. 3 km per hour and 4 km per hour. Time is given. First is earlier, first is late, second is earlier. So we will add both the time divided by 60. Why 60? Because it's given in minute. Here is 2, here is 2, which is equal to 6 kilometers. So the distance between, the distance between the Ram has traveled, which is equal to 6 kilometers. Clear? The destination and from where the Ram start, which from where the Ram start and his destination, the distance is 6 kilometers. Now, in this video, we cover the topic when the speed is constant, time is constant, distance is constant. So, in the next video, we will discuss relative speed. Here, relative speed is very important. Now, in train, we will use the relative speed also. After that, we will complete the relative speed and we will start the question based on trains. So, for today, thank you so much. In the next video, we will start the relative speed. Thank you.